In my book, I have, I think, about 4 different basic functions that I give examples for throughout this section. The absolute value one, which you've seen, the basic parabola, y equals x squared, and then I have a cubic equation, which I like to use. Cubic polynomial means third degree polynomial, and then a semicircle. And I thought I would use a semicircle for this problem because the semicircle is probably the most complicated of those 4 types of basic functions. Of course, there are going to be other kinds of functions, but I'm going to use the semicircle because it's a little tricky. And I also designed this one so it's a little even extra trickier, just give you a better exposure. Alright, here's the problem now. Given the graph of y equals to square root of 9 minus x squared, here it is, find the function for this graph. Alright, now this is a semicircle, and in fact if you squared both sides and collected the terms, you would have x squared plus y squared equals to 9. It would be a circle centered at the origin with a radius of 3. And but when you solve for y, you've written it in function form. We could call this f of x if you wanted to. And what that does, it restricts the range so that it becomes a true function. It would pass the vertical line test. So this basically is the upper half of a semicircle. Now what is this? This is not a semicircle. Alright. First of all, where is the center? And the center is going to be up here, you know, right between these 2 endpoints. And it does have a horizontal radius of 3 units, but I drew it so that the vertical is actually 5 units. So it's been stretched by a fractional power, actually, factor. But it's been stretched so it's no longer a true semicircular shape. You would call this a semi-ellipse, I guess is probably what you would call it. An ellipse is an oval shape. And alright, now the center is kind of the key here, because remember what I said about centers. I'm sorry, what about the origin point? The origin point never gets stretched or reflected. You know, that has no effect on the origin. The only thing that affects the origin are the horizontal and vertical shifts. So even though this graph doesn't go through the origin, we can still identify what happened to the origin point. Well, it's the center of this graph, and so it got shifted over to here, and the center is now at -1, 3. So that tells us the horizontal and vertical shifts right there. Now it's obviously been reflected. This is upside down, this is right side up, so we have, let me write out these transformations here. Let's see if I can find some room. So there was a, and we don't have to number it. Alright, so it's reflected across x-axis. And then, what about the vertical stretch? Alright, now here, this from the center to the top is 3 units. Here, the center to the bottom is 5 units. So, what do you multiply 3 by in order to get 5? It would be 5/3. So the vertical stretch by a factor of 5/3, 5/3. Again, think about it. If you multiply 5/3 times 3, the 3 cancels and is replaced by 5. So multiply by 5/3. Alright, it's a little unusual for me to give you a fraction like that, but I thought I would do it in this video just for the fun of it. As far as the translations, it was shifted left by -1 and down by, I'm sorry, not down, went up by 3 units. Up by 3. +3. Alright. So there's the 4 basic transformations that carried us from the basic function over to this graph. Now all we have to do is take this information and write out the correct functions. So I'm going to erase this to make room and write out this new function. Alright, here it is. Y equals 2. And you know what? I erased the original function. Let me put it back up there. Okay. Alright, so in fact I'm going to put a little English on this. The new function is, you ready? Here we go. Y equals 2. Reflected and stretched by 5/3 means we're going to multiply the square root, the original function, by negative 5/3. So negative 5/3 square root 9 minus, now did we change x? We changed x by going to the left by negative 1. So left negative 1 means we replace x with x plus 1. So 9 minus x plus 1 squared. And I have to erase my graph a little bit. Sorry, I'm kind of cluttered on my board. Please don't clutter your paper like I have to clutter my board. And we shifted up by 3, which means 3 gets added to this entire thing, plus 3. Now about the vertical shift. You add 3 to everything else, which means the 3 doesn't go inside. It's not multiplied by negative 5/3. It simply stands outside of it. 3 is added to everything else. So be careful when you write out these functions that you don't include the vertical shift under some multiplication or division that would actually change the vertical shift. Be careful about that. All right, but here's our new function. And reflected, vertical stretch by 5/3, horizontal shift, left negative 1, vertical shift up by 3. And there's that. Alright, so that's one of the 3 types of problems I want you to be able to do. And we'll go on to another one.